We've got a great demo to showcase our new native connection manager, which is a game changer. We're going to show you how Yugabyte greatly outperforms standard Postgres on measures for connection establishment and scaling with no impact on the throughput of workloads. Let's take a closer look at the numbers and test setup we've used. All our tests were run on identical hardware for Yugabyte and Postgres. We used 16 vCPU machines with 64 GB of RAM in the AWS Cloud. As Karthik mentioned, our tests for connection initialization show that Yugabyte with connection management enabled consistently performs at least 5 times faster than Postgres. This graph shows how Yugabyte quickly establishes thousands of connections while Postgres on RDS lags behind, especially at higher connection numbers. Note that faster and thereby lower initialization times are better. Yugabyte is at least 5 times faster than Postgres when starting up 250 connections, and it's 20 times faster at spinning up a batch of 6,000 connections. Now that we've set the stage, let's look at how Yugabyte can quickly scale to handle increased loads on databases with our new connection manager. We'll use the well-known Postgres performance benchmark Sysbench with a wrapper script for this. We will simulate multiple instances of an app like Mastodon, directly connecting to Yugabyte and running workloads. Let's get started. First, we'll try Postgres with 5,000 initial connections. Once the first set of connections is successfully established, we'll attempt to add new batches of 6,000 connections each. Here, we see the attempts to start new connections to the database failed when there are 5,000 existing connections. We'll leave the first batch of connections active and running. Let's kick off the same experiment with 6,000 initial connections hitting Yugabyte. We're going to ramp up connections to the Yugabyte database using separate instances of the app once the initial tranche of connections has spun up. You'll see that Yugabyte starts to effortlessly scale up the number of concurrent active connections as we add more instances of the app. And there we go. The workloads have completed successfully with no impact on throughput. Let's check back in on Postgres. The run of the first instance of the app has finally completed. As seen earlier, attempts to start new connections with this instance running failed. With this demonstration, we've shown how Yugabyte can easily scale up to about 24,000 concurrent connections with no issues. The results of our extensive testing show that Postgres tops out at about 6,000 connections before complete connection failure, and also takes longer to scale up to those 6,000 connections. Yugabyte, running on identical hardware, scales up faster to higher numbers of concurrent connections, 5 times as many. And finally, we ensure that Yugabyte's connection pooling capabilities are ready for real-world scenarios. We've confirmed that there is no impact on the throughput of workloads, even with extremely high numbers of connections to the database. This graph shows the results of our TPS benchmark tests with increasingly higher numbers of connections. And there you have it. An application such as Mastodon can grow and scale up with Yugabyte's connection manager to handle large numbers of connections while offering a consistent connectivity experience for all users. If you're interested in learning more about connection management in YugabyteDB and our benchmark tests, please take a look at Yugabyte's documentation pages.